madam.
Oh, is this
Yes,
visible now?
yes, yes, ma'am.
Okay.
Yes, yes.
Okay. So we'll
Yes,
talk
ma'am, now
about.
it is changed.
Yeah. Okay. Thank you so much. You can talk in between also if you have any questions, or at last also. We'll talk about why data is important, what are different types of data and data collection techniques, what are the methods used for data analysis. We'll talk different methods for univariate, bivariate analysis. And majorly, we are going to talk about inferential statistics, some case studies, and I'll tell you about few functions or the methods. How do you use them in R? So nowadays everybody is talking about data. So why data is important? I hope everybody uses data for different purpose. In everyday life also we use data for different purpose. Researchers, they also heavily rely on the data, as researchers are normally working on a problem to solve. So data has all the answers for that solution. So maybe data, it's not only that researcher use that data is useful for all of us. You get the result, you find the solution using that data, you form the informed decision from the data. It helps, it works as a backup for your arguments. It helps you to be strategic in your approach. It helps you to find out what you are doing well. All questions, all these question answers are there in the data. But even if you do not have any questions, you data is even important, because data helps you to find out certain patterns also. So you can use different data mining techniques which reveal some interesting patterns within the data, so that data is worth exploring in many aspects. So it's not that we start working with data as we get the data as it is. We normally process the data. Process the data in the sense data is in raw form. So it is possible that your data is not up to the mark the way you want your data to be. So what we need is, we need to categorize the data, or you may need to organize the data, you may need to summarize the data. Only then, after doing those pre-processing things, data is ready for your work. For analysis also, you need to have those pre-processing things to be done on the data. Before talking about the analysis techniques, you should first understand what are the different types of data. And why it is important, because when we talk about statistics, if you define statistics is a kind of science or a device which deals with the collection, analysis and interpretation of the data. So statistical techniques are different for different types of data. It's not that all techniques are applied to all types of data. Some techniques require some specific kind of data. So you do some data pre-processing on the before applying those statistical techniques. So what are different data types? So I hope everybody knows about that. Data can be of two different types. One is qualitative data, another one is quantitative data. Qualitative data is data which is not in the form of numbers, which is describing certain properties or attributes. So that qualitative data can be
discrete case, continuous case. Continuous na intervals இருக்கும்.
நார்மல் ஆர்டினல் கிடைக்குமா? கிடைக்குது.
இது
கட்டாய் போச்சா?
discrete continuous. Continuous na என்னது? discrete na summation value போட்டு போடுவாங்க. continuous case na integration போட்டு போடுவாங்க. அதனால தான் intervals வரும்.
கட்டாய் போச்சா இல்ல என்ன?
participant, can you please mute yourself?
Statistical method. Discrete method or continuous method or
Can you please mute yourself, please?
Yes ma'am, yes, you please continue. मैंने उनको mute कर दिया है.
Okay, yeah. So when you talk about data, so we have different types of data. One is qualitative data, another one is quantitative data. Qualitative data talks about certain properties. They are not in numbers, but then you can convert them into numbers but those number doesn't have any numeric value which you can add on, or that doesn't make any sense for those data items. So qualitative data can again be categorized into nominal or ordinal. We'll see with examples what kind of data we say it is nominal or ordinal. Qualitative data can be of which is in the form of number or numeric. So that can be discrete or continuous. Uh, now why I said that you should know your data, because I told you that different type of statistical methods are applied on different data types. So that is a very if you define statistics can also be used as a double-edged tool in the sense statistics can be abused or it can be abused and misused in the sense because statistical techniques works on the data. So proper technique should be applied on proper data type. So it can be abused in the sense you are using very sophisticated statistical techniques but you have given very poor data, so that will lead you wrong conclusion. Or vice versa can also happen. It can be misused in the sense you have very honest and hard fact data with you and you have not applied proper technique for those data, so again that will give you wrong result or wrong conclusions. So that has to be, techniques has to be combined strongly with the different with the proper data type also. So you, that will help you to do the correct form of analysis. So that's why I told you different data types. Categorical data, that is which is not in the form of numbers, which represent the characteristics. So for example, marital status, hometown, nationality, or the movies they like, languages they speak, we ask them. Those data types are basically categorical data. They are not in numbers. Gender is male or female, though you can convert like female, you can convert that female to 1 or male to 0, but then this 0 and 1 doesn't have any mathematical meaning. Now how do you differentiate between, now categorical data can be of two different types, nominal data and ordinal data. Nominal data doesn't have any order and ordinal data has an order in the sense, for example, data type data which we are asking is, are you married? You are saying yes or no. Now saying yes or no, it doesn't have any order, so that is a nominal data. So and for another example is, what languages do you speak? Do you speak English, French, German, Spanish, or whatever? So these languages, they will take on 1, so that is also a nominal data. Order doesn't matter in them. If you have categorical data which where order does matter, that comes in ordinal data, category of ordinal data. For example, what is your educational background? Can be elementary, high school, undergraduate, or graduate. Now it has certain order associated with that data type, so that is a ordinal data. Normally happiness or customer satisfaction, these kinds of things are normally measured on ordinal scale. Now, when we talk about numeric data normally is categorized into two. One is discrete and another one is continuous data. Discrete data is a data. People normally get confused between discrete data and continuous data, but differentiation is quite obvious in case of numeric data. Discrete data is when you when you look into the data, and if you think that that data can be counted, it cannot be measured, so that will be a discrete data. For example, number of chocolates in the box, you can count them, you cannot measure them. So that and talk about the height and weight of a person, you cannot count that, you can measure height and weight of the person, so that will come in the category of continuous data. So like for example, number of heads when you flip a coin, 100 coin flips, and so on, these kinds of data comes in the category of discrete data. Now when we talk about, like for example, if you have a discrete data, you will be able to apply different statistical techniques. If you have continuous data, you will be applying different statistical techniques. So once you understand your data properly, you will be having proper selection of the proper statistical technique. So continuous data, as I told you, it cannot be counted, but it can be measured. Like for example, height and weight of a person are continuous data. Okay, I have example. Let's see if time permits. We'll take your questions. Now, when it's not that data comes directly to data collection process. Data collection, normally what we do is we take data from the Kaggle or from some free resources. So that is kind of secondary data we are working on. But you can work with primary data also. So what is the difference between primary and secondary data? Primary data is the data which is collected afresh for the first time, which is original in nature. So if you want to work for primary data, you should have that much of resources and money and time with you to collect the primary data. Secondary data is the data which is already available, which you are which have been passed through a statistical process sometime, and you are reusing that data. So obviously, using primary data and secondary data, it depends. Secondary data examples are this: country health. You can take the data from somewhere else, like from country health departments, from birth and death certificates, from hospitals, from banks, from clinics, from school, from government departments, and from census, and from NIH, surveillance from the state government, other offices. You can collect those secondary data. So which data you should choose, primary data or secondary data, that depends on the nature and scope of the inquiry, what kind of data you need. If secondary data solves your purpose, use that. If it is not solving your purpose, you may need to collect data primarily. But it also, primary data, all data collection methods has its own pros and cons. How much financial resources you have, how much time you have, what is the accuracy you need. Do you have those, all those things, go in for primary data, otherwise go in for secondary data. It's your application requirement and your choice. Now let's talk about statistical method used for data analysis. Now when we talk about statistical methods, we can have two different kinds of methods applied on the data. One is descriptive statistics, another one is inferential statistics. Descriptive statistics is used to describe the data, and inferential statistics helps you to draw conclusion from the data. Descriptive statistics has different techniques, and inferential statistics also has techniques available which helps you to draw the conclusion from the data. Like for example, descriptive statistics works normally on the univariate data. Univariate data in the sense, when we talk about univariate data, we say that we have only one variable to study. When we say that it's a bivariate analysis, we have two variables to study. Multivariate, we have more than two variables to study the thing. So descriptive statistics normally work with univariate data. Normally in the sense, like for example, what comes under descriptive statistics? Descriptive statistics describe your data, describe single value, describes your whole data. So it is also called univariate, because when we say that single value is describing your whole data, we say that we are working only in one variable. For example, data is given, we say that say for example, marks of students is given, we ask that what is the mean mark, what is the mode mark, or what is the median of those marks, and so on. So what we have is marks, only the marks variable. So we calculate the mean, median, mode, all comes in the category of descriptive statistics. Now, descriptive statistics has 2-3 things to do with it. One is you can measure the central tendency of the given data. Central tendency in the sense, what comes under central tendency? What comes under central tendency is mean, calculating mean, median and mode. I have not used those formula. I hope everybody knows about mean, median, and mode. Mean is average values. Average value in the sense summation. You do the summation of all and divide that by number of observation. Median is the middle value in the observation. You sort the data in ascending order, find out which one is the middle value in the observation. Median also has different formulas because your data is not always in the form of single value. It can be in the form of class intervals also. It can be in the form of group values also. So you can calculate median using different formulas. What meaning of median is that what is the middle value in the observation. And mode is what is the most frequently used value. So you can count on which values, like for example, shirt size in the sense how these many people are using large size, these many people are using median size, and these many people are using small size. So what is the mode size means? So how many, like for production, if company wants to produce some shirt sizes more, so which shirt sizes they should be producing more, which has which has more which size has mode value highest. Mode value is highest in the sense most of the people are using purchasing medium size shirts, so they will, it is good that they produce medium size shirt more than large or small size. So that's how it depends on the application. Okay, what kind of central tendency value is useful for your application, go in for that. Example, for example, here if you look into the wages of the staff, salary of the staff, first staff is getting 15, second is 18, 16, and so on. So the now here if you calculate the mean salary of this data, what you will get is you can have a look on this data and you see that only 90 and 95 salary is only of 2 staff member. Rest all are having salary between 12 to 18K. So if you calculate the mean of this, you will get 30.7, which doesn't give a good picture of the data, isn't it? So because it means salary 30.7 is of none of the stuff in the sense that mean, median, mode might not be having the actual value in the data itself, but then it should give you descriptive statistics. Meaning is that it should give you a single value representation of your whole data. So 30.7 is giving you the mean value, but then you can see from the data that mean salary 30 doesn't give you clear picture. So instead of calculating mean for this, you can see here median salary for this is between 12 to 18K. So it should not be 30, it should be between 12 to 18K, some number between 12 to 18K. So mean is obviously not giving you that picture. So go in for calculating median for this data. So you have to identify what kind of descriptive statistics is helping you to give you the good picture of your given data. So median is used here. So median will be giving you the value from 12 to now where median is actually, if you look carefully on this data is not normally distributed. This data is skewed, isn't it? So only two values are having the value 90 and 95K. Rest all the data are from between 12 to 18K range. So when your data is skewed, mean is not going to help you. You should go in for using median or mode. Now mean is used for numerical data in the sense you add up all the values and then you divide by number of observations. So mean cannot be calculated for ordinal data or for nominal data. So mean is possible only when your data is of numeric data only. So you should be knowing what kind of data you have. It should not be that your data is categorical and you are trying to calculate mean on that. It will be illogical to calculate mean on the categorical data. And median gives you a good picture if your data is skewed. If your data is perfectly normally distributed, normal distribution in the sense you have mean, median, and mode, all values are same. So when your data is skewed, mean is not going to give you the good picture. So better you go in for using median. So see this. When to use, this is just a small example where you can use which kind of descriptive statistics. Like if you have nominal data, you can have ordinal data, or you can have your numeric data. So if you have numeric data which is not skewed, go in for using mean. If your data is numeric and it is skewed, don't use mean, use median. If your data is categorical, this is for categorical data. Nominal, ordinal are categorical data. So when your data is categorical and it is nominal, what option you have? You have only option to calculate mode, because median is ordinal data you can order, nominal data you cannot order. So it's not possible to calculate mean here. So when your data is ordinal, you go in for calculating median. So identify your data properly and then find out which central tendency helps you to give good picture of your data. Another descriptive statistic measure is you can calculate range, variance, or standard deviation. Now it is sometimes you need to find out what is the dispersion in your data. Dispersion in your data in the sense, it is possible that two data items values are quite different, but their central value is same. Like for example, two data items can be there whose mean are same, but then their data values are quite different. It is possible. So how will you differentiate those data items? In that case, dispersion helps you to find out that which data is widely dispersed and which data is less dispersed. So measure of dispersion also, like for example, if you have heard about PCA, principal component analysis, in this machine learning. So this principal component analysis majorly rely on the dispersion of the data or the variance of the data. So this variance is helpful in certain calculating variance is helpful in certain machine learning techniques also. Now, how do you calculate the dispersion of the data? One is you can calculate standard deviation, you can calculate variance, you can calculate range also. Standard deviation and variance calculation are just a standard deviation square is variance. So once you know standard deviation, you can calculate variance also. Range means minimum and maximum value. What is the minimum and maximum value of your data? And how do you calculate standard deviation? Standard deviation is basically deviation from the mean. It is calculated as deviation from the mean, that is each value subtracted from the mean, square of those deviation divided by number of observation or number of observation minus 1, square root of those will give you the standard deviation. Deviation from the mean, square of those deviation divided by number of observation, square root will give you the standard deviation. So standard deviation gives the dispersion of the data, how much dispersed your data is. If data is closely bind together, your standard deviation will be quite low. But if your data is widely spread, standard deviation will be high. So apart from having calculation of this range and standard deviation, you can calculate interquartile range or quartile deviation also. You can calculate mean deviation also. Mean deviation in the sense deviation from the mean. Deviation from the mean, sum those deviation divide by like average of those mean deviation is your mean deviation. Interquartile range, what is assumed, what it does is, interquartile range, what it does is, it divides your data item into quartiles. Like for example, you have data items 1, 2, 3, 4, 5, 6, 7, 8, and so on. If your data items are like this, so it divides your data into 25%, this is 50%, this is 75%, and so on. So it divides first 50% value is your 50% value is your mean. Sorry, median. 50% value is your median. So it divides your data into 4 different quarters. This is first quarter, this is first quarter, this is second quarter. Again, this will divide it into 2 quarters. This and this and this again. So interquartile range also helps you to find out what is the dispersion of your data. So what we talked about till now is what we talked about. This is applicable only for a univariate analysis. Univariate analysis in the sense we have only one variable to study. We have only one variable to study. Just give me a minute. Yeah, so sorry. So what we talked about is it was having only one variable to work on. Now it's not always the case that we work only with one variable. We work with two variables or we work with multiple variables also. So when two variables comes into picture, we normally we have we want to analyze how those two variables are working together, how they behave together. So there comes the picture of calculating correlation and regression analysis. Correlation analysis helps you to find out how those how these variables behave together. In the sense, if one variable is increasing, other variable value is also increasing, or one variable increasing, other is decreasing, or there is no correlation at all. So correlation and regression go hand in hand. So once you identify the correlation, you can go in for doing the regression analysis also. For example, you want to investigate the relationship between the cigarette smoking and lung capacity. You want to analyze the age and blood pressure. So these two variables we want to analyze how they affect each other, in the sense if one is increasing, other is also, or they have with age blood pressure is increasing, or with cigarette smoking lung capacity is increasing or decreasing, how, what is the relation between them. So correlation helps you to find that. Now how to find out the correlation and regression? We have mathematics associated with it. Like for example, if you want to calculate the correlation between two variables, you can calculate Karl Pearson or Sperman correlation coefficient values for the given data. By applying the formulas on the given data will give you the value of correlation. Correlation coefficient normally varies from -1 to +1. So when you say about correlation, that is association between variables, like for example, height and blood pressure, age, and so on. So you have different, we have three different kinds of relationship. One is positive correlation, another one is negative correlation, and zero correlation. Positive correlation, if the value of one attribute increases with the increase of other value B also, that is positive, means both are increasing or both are decreasing, or one is decreasing, other is increasing. So that is kind of negative correlation. When you have no relation between two attributes, we say that it is a zero correlation. Now how do you identify that it is a positive, negative, or zero correlation? You have several methods available with you. Several methods in the sense you can plot that using scatter plot. So if you scatter plot the data, like for example, if this is age and this is blood pressure, age with blood pressure is, now the relationship between age and blood pressure, you can see these points. So if data is like this is a scatter plot between age and blood pressure. So age is increasing, blood pressure is also increasing. So this is a positive correlation. When here in second diagram, what you can see is age is increasing, but blood pressure is decreasing. This is decreasing, age is increasing, blood pressure is decreasing. So this is a negative correlation. This is a positive correlation. And here you can see this has no correlation. Why? Because this plot is quite scattered. You cannot say this is positive, you cannot even say this is negative. So this is a zero correlation between the variables. One way is you plot this and find out the relationship. Another one is you can calculate the correlation coefficient also using Sperman or Pearson correlation coefficient. Correlation coefficient valued calculated value, if this values of, for example, correlation coefficient value you are getting is minus 0.8. So minus 0.8 values can be between -1 to +1. -1 is strong negative correlation, +1 is strong positive correlation. So if value calculated is minus 0.8, so it is not strong, but it is it is not that strong, but it is not that weak also. So you have a negative correlation between them. If calculated value is 0.25 only, 0.25 is quite weak. So it is a positive correlation, but it is not too high. So when you go in for analyzing those variables, find out their correlation coefficient, and then after finding out, once you find out that this variable is related with this another variable, you can predict, like for example, age and blood pressure. Age and blood pressure correlation coefficient, if you see correlation coefficient, if it is coming as 0.8, for example 0.82, so it what it says is age and blood pressure, they are highly correlated, in the sense if age is increasing, blood pressure is also increasing. So how does that help you? It will help you to predict the values. So once you find out these variables are highly correlated, you can find out their regression analysis. You can predict those variable using regression by fitting a regression model. So now here comes regression analysis. Regression analysis is used for prediction, majorly used for prediction. And you must have understood by now that correlation works on the numeric data. So you cannot have correlation to be calculated on categorical data. Likewise, regression analysis also expect that your data is continuous. It is not discrete, in the sense you are predicting something. Like for example, house price you want to predict based on where is the location, what is the area, and other parameters also. So that output is always continuous. Expected output by regression analysis prediction is always of continuous variable. So if you have your data categorical, don't try or don't even think of applying regression model for those applications. So regression is used majorly for prediction. So it is a statistical modeling method used to formulate the mathematical model of the relationship among the variables. So regression analysis can be of simple linear regression, it can be multiple linear regression, it can be non-linear regression also. Simple linear regression, in the sense this is a simple linear regression model. That is, we have only two variable. One is independent variable, that is x is called independent variable, y is dependent variable. So you have only two variables, that is x and y. This is dependent variable, this is independent variable. So simple linear regression is what you are trying to do is you are trying to fit a model y equals to mx plus c kind of line here. But it happens that what it says is like for example, y is blood pressure and x is age. How blood pressure is getting affected because of age. X will be treated as age and y is your blood pressure variable. Now it is possible that we normally do not work only with two variables. For data analysis, we have multiple variables. Multiple variables in the sense age is blood pressure is not affected only by age, but it is affected by other variables also. House price is not only by area, it is by other variables also. So when you have more than one independent variable, that comes as the that comes in the category of multiple linear regression, that you are trying to predict value of y with X and Z as independent variable. Y is your dependent variable. X and Z will be treated as independent variable. So you have equation, you will be having equation instead of y equals to mx plus c, you will be having m1 plus x1 plus m2 plus x2 plus c kind of line. But then this is a simple linear regression. Simple in the sense linear regression. Now you can have data values which are not linearly related with each other. So there you have this kind of parabola or hyperbola or some other mathematical equation fitted on y and x line. So that comes as non-linear regression. You have strong mathematics behind this, how to find out this y and how to find out this m and c values, to find out now how this regression analysis is helping you to predict is. Now what is our purpose in linear regression? We want to predict something. What we want to predict? We want to predict y value based on given x value. This is given and you have to predict this value. Like this was BP and this is age. So given the age, now once you fit your model, how will you fit your model? If you know this equation y equals to w0 plus w1x, if you know this, y is equal to 2 plus 3x, for example. So if you know these values 2 and 3, so if I ask you to tell me the blood pressure of a person whose age is 56, so you can find out that as x given is 56 age, and so what you are going to do is you are going to predict the value of y by 2 multiplied 3 multiplied by 56 added 2 will give you the value of blood pressure for that person. So this value, this is your regression model where you have to fit the model use by calculating this w1 and w0 as the parameter. W0 is called as intercept and w1 is called as the slope of your line. From where you are going to calculate this w0 and w1, you are going to calculate this from the history data. History data in the sense the data given. Okay, so data given in the sense age and blood pressure, previous data values are already given. So you fit this on mathematical by using the method of least square. What this method of least square says is that yeah, these values are given. For example, these values are given. These values are given. This is your x, this is your y. So now what we want is we want to now here for fitting we have to fit a simple linear regression line. So we can use the method of least square which best fit your straight line. Why? Because your line can be fitted here also, your line can be this also, your line can be this also, but then which one is your best line? Say for example this is your best fit line. If this is your best fit line, so how from where you are going to calculate this best fit line? You are going to use the one of the method which can be used here is method of least square. Method of least square, what it says is, it says that every value of this with this error should be minimized. What is the error? That this line point is here but actual point is here. Likewise, for this point, this much is the error. For this point, this much is the error. For this point, this much is the error. For every point, error has to be calculated and we have to add up all these error and we need to minimize this error. If you use that concept, sum up all the errors and then try to minimize this, you will get this W1 and W2 from those values. So once you know this, you will be able to predict the value. So linear regression helps you to do the prediction. Likewise, if you add more variables, this was simple linear regression where you have only one independent variable. Now, if you have more independent variable like x1 and x2, like BP depends on age and what sleeping habits or sleeping hours also, for example. So x2 will be sleeping hours and this is age, and y will be your blood pressure. So your equation will be like this. Now here you have to predict. Now you have to here you were having only two parameters, that is w0 and w1. Here you have to calculate three parameters, W0, W1 and W2. So as and when you keep on adding those things, You need to calculate those parameters using the same method, that is method of least square, which will help you to find out the values for W0, W1, W2 and so on. Now you do not have to, we have functions in R available for doing this linear regression or finding out the correlation. You don't need to write the full program for finding out the, for calculating the values like equation forming and all those things. You don't need to do. R has direct function called LM. LM, linear model, will help you to find out the linear regression. How, just pass on the values, just understand this, what, how and what you are passing, and just fit the model, will give you the predictions of the values also. So this is linear relationship. So least square method works on this, that each value from this line, best fit line, error should be minimum. So you are adding up all these errors. This is error, this is error, this is also error, error. Add up all these errors and try to minimize those errors, will give you the values of parameters. So we have two regression coefficient. One is the slope of the line, which tells you the nature and relationship between the variables. And you have intercept values also. So you can, after fitting the model using LM function, you can print the summary of the model also, which will print the coefficients also, that this is your fit line. Coefficient in the sense, if your line, fitted line is something like this, 7.8 plus 2.1 x, something like this. So if you print this summary using, after fitting the model using LM, if you print summary of your model, it will print these variables 7.8 and 2.1. So it will print the parameters, that what from the given data your model fit is like this, 2.1 and 7.8. These parameters will be printed if you print this using summary. So polynomial regression can also be used. Like for example, we talked about y equals to W0 plus W1x plus W2x, x1, x2 and so on. So that was simple linear model. Here you can have this polynomial regression also, x, x square, x cube and so on. Other functions such as power function can also be used. Depends on your data. Oh, okay. So what we talked about is linear regression. Linear regression, I told you, linear regression works on numerical data. It doesn't work on categorical data, numeric continuous data. But another regression model exists, that is logistic regression, which works on discrete data. Discrete data in the sense, like for example, male is sperm or not, or whether a person smokes or not, or loan application, the person has to be granted loan application, has to be approved or not. Those kinds of things where you have discrete values 0 and 1 type of categorization. So logistic regression is majorly used for classification. Though name says that it is a regression, but it is used for classification, not for prediction. Let me first cover few more important topics. If time permits, we'll talk about this linear regression later. Sorry, logistic regression later. Now let's talk about some inferential statistics concepts. What we talked about is descriptive statistics, that is used to describe the data, to summarize the data. You can also, descriptive statistics also involves plotting certain, summarizing the data using different charts and graphs also. So that is also part of descriptive statistics. You will find several functions in R, and maybe in Python also you have functions available which helps you to represent your data quite well. Next comes the inferential statistics. Now this inferential statistics is very interesting. What it does is, it uses the probability concept to deal with the uncertainty. It helps you to make certain conclusion. It helps you to draw certain conclusion from the data. So inferential statistics, you take data samples and you make conclusion from the data. Now how that inferential statistics works? Inferential statistics has two parts. Like for example, it has two parts. One is estimating the parameter, another one is hypothesis testing. We'll talk about hypothesis testing. Now hypothesis testing is that you test the hypothesis. Now what do you mean by hypothesis? Hypothesis is just the statement, is a statement which you want to, it's just a statement about the relationship between the data or variables. Given the data values, you have to make certain assumption or make certain statement that, and you can validate whether that assumption or the statement which you have made from the data is that correct or not. You can either accept or reject those statements. So if it is accepted, it means that assumption which you have made is okay. If you are rejecting that, it means that assumption which you have made is not okay. Now how you are going to accept or reject, it depends on the data, and it depends on the techniques results applied for that data. So now, for example, you might stand in a mall and ask sample of 100 people if they like shopping at Phoenix. Now, for doing this analysis, 100 people, you are asking 100 people that do they like the shopping at Phoenix? You can ask all 100 people and you can make a bar chart. Of some people will say yes, some people will say no. Okay, so that would be a descriptive statistics. You can make a bar chart that these many people said yes and no, something like this, yes and no, for example, like this. So this is a descriptive statistics. You can apply descriptive statistics whether the people like shopping at Phoenix or not. But you can apply inferential statistics on the same data. How do you apply inferential statistics? That you could use your research for the data, how many people said this, yeah, how many people said no, and so on, and you can reason that around 75 to 80% of the people like shopping in the Phoenix. By using those all 100 data items, you can make that conclusion also. Now doing that conclusion for 100 data in differential descriptive statistics also helps you. But then descriptive statistics give gives you a different picture, and inferential statistics also gives you a good picture, but then that is quite validated compared to now 100 people doing that in 100 people is quite okay. But what if you have number of samples more? So if you have those number of samples are more, descriptive statistics might not give you good way, is because representation of all those samples, number of samples are high, all those samples might not be good. So you can go in for doing inferential statistics to validate whether actually people like shopping at Phoenix or not. Those kind of statements can be concluded, or you can make a decision for those statements whether actually people like shopping at Phoenix Mall or not based on the data. So now let's talk about hypothesis testing, which is a part of inferential statistics. There are various methods available for doing this inferential statistics. Now, hypothesis testing is one way to do inferential statistics. Now, what is hypothesis testing? You test the hypothesis. Now, what is hypothesis? It is a statement or an assumption which you make from the data about the relationship between the variables. Now, you can make two different kinds of hypothesis. One is null hypothesis, another one is alternative hypothesis. Null hypothesis is denoted as H0, and alternative hypothesis is either denoted as H1 or HA. Both are valid. Now, null hypothesis, for example, null hypothesis you made, null hypothesis, alternative hypothesis is a hypothesis. When null hypothesis is true, you are going to accept the null hypothesis, but when null hypothesis is false, you are rejecting null hypothesis, you are going to accept alternative hypothesis. So alternative hypothesis comes into picture when you are rejecting the null hypothesis. Remember, hypothesis is a statement which you make from the given data about the relationship between the variables. Now you should not be making hypothesis very vague or ambiguous. It should be very clear in statement, and you should be able to relate with the variables that are what should I say, that are the characteristics of the hypothesis. Now, for example, you are making a null hypothesis like that population mean is mu0. So alternative hypothesis respectively for can be that mean is not equal to mu0. That is alternative hypothesis. If you make a null hypothesis that your mean is less than equal to mu0, alternative will be that your mean is greater than mu0. If you are forming a null hypothesis where mean is greater than equal to mu0, your alternative will be mean is less than mu0. So the way you form your alternative hypothesis, it helps you to find out which kind of test you are doing. For example, if you do, you can do one-tailed or two-tailed test on the given data. So one-tailed test says that you are on the one side, like normal distribution is like this. Normal distribution is like this. So when you say one-tailed test, you are either doing on left side or you are doing it on right side. When you say you are doing two-tailed test, you are doing on both sides, this side and this side both, basically. So the way you form your alternate hypothesis helps you to find out which kind of test you are doing. Now, when you say, for example, this is first hypothesis I'm talking about. Your null hypothesis is mu equals to mu0. It says that your mean is equal to given mu0. Your mean is equal to, say, for example, 5. Population ka mean is 5. Your alternative hypothesis, you are saying that your mu is not equal to 5. So now this way of forming your null hypothesis is actually saying you that you are doing two-tailed test. How it is indicating two-tailed test? How it is indicating that it is a two-tailed test? Because if you form null hypothesis like this, that your mu is greater than 5, or if you say that mu is less than 5, so you are on one side, either you are here or you are here. We are saying that mu is not equal to 5. It means that your mu can be less than 5, it can be more than 5 also. What you are saying is mu is not equal to 5. That's what. So when you use this kind of hypothesis, you are saying that you are performing two-tailed test. If you are forming your hypothesis like this, you are saying that you are doing one-tailed test. And when you do hypothesis testing, for example, in a clinical trial of a new drug, null hypothesis might be that new drug is no better on average than the current drug. So this is your null hypothesis H0, that there is no difference between the two drugs on average. Or alternative hypothesis, you can form anything based on your data. You feel that your data is revealing, your data is indicating that new drug is effective, or your data is indicating new drug is not effective, or you are not able to find out the difference whether it is effective or not. So you are forming a alternative hypothesis that two drugs have different effects on average, or new drug is better than current drug, or current drug is better than new drug on average. So the way you are forming your alternative hypothesis, respective null hypothesis is always formed uniquely, is always one. The way forming null hypothesis is only this. Alternative hypothesis is your choice, how you are forming your alternative hypothesis. I hope I am clear.
Yes.
Yes, ma'am.
Yes, okay. Okay, so when you do hypothesis testing, these are the steps which is done for all kinds of hypothesis testing. You apply any kind of test, but these steps are valid for all tests. What you do first is you first formulate your null hypothesis, that is H0 and HA. You form your hypothesis first. and then you determine significance level. Significance level, at which level of significance you want to work. You want to work at 5% level of significance, or you want to work at 1% level of significance? You need to decide on that. Why it I'll tell you with the example. I will tell you with the diagram that where this is important. So after forming this hypothesis, you find out at which level of significance you have to perform the test. You find out which test is appropriate, apply that test, calculate the test statistics, find out what is degree of freedom, and then after applying the test, you calculate the value of your statistics, and then you compare your computed test statistics which you got from this step, this computed statistics you have to compare against the given critical value, and based on this step comparison, what is the result, you have to make your decision. Now what, let us take an example. Now this level of significance, I told you, this level of significance where you are doing 5% or 1% level of significance, you are basically, what you are doing is you are finding out, for example, this is the my normal distribution curve. So if you are saying that this area is your acceptance region, this line, this area is your rejection region. You can see here, this is rejection region, this is rejection region on left side and right side, both side you have a rejection region. From this onwards here is rejection, from this onwards here is rejection, between this is all acceptance region, this is acceptance region. So now this is your critical value, this is your critical value given. Critical values are given in statistical tables for different type of test. Now, if you say that I am doing test at 95% level of significance, 5% level of significance says that what is my chances of error? So what is my chances of error? I'm saying that I have only 5% chances of error, in the sense now this 5% level of significance means 95% comes into acceptance region. So this 5%, when you are doing two-tail test, 5% ka 2.5% will be on this side, 2.5% will be on this side. So rest of the 95% is here. Rest of this 95% is here, means your acceptance region is 95%. Your rejection region is on 2.5 on both sides. So this critical value is defined differently for different level of significance on statistical tables. When you say you are doing at 1% level of significance, it means what? This acceptance region will be 99%. So you are maximizing the probability of accepting the null hypothesis. So if your null hypothesis is between this 99% region, value is between this 99% region, you say that you are accepting the null hypothesis. But when it exceeds that, now if you are doing at 99%, in the sense remaining 1%, so 0.05% will be here and 0.05% will be here when you are doing two-tail test. 0.05 here, 0.05 here. So you are actually finding out this is helping you to find out how much is the area of your acceptance region. So if it is 2.5, your critical value is here, somewhere here, but if it is 0.5, your critical value will be somewhere here. Means you are increasing this acceptance region by this value. So this is what I told you already. Now let's talk about some of the tests which you can perform on given data. Now these tests are assuming something, in the sense chi-square test is a non-parametric test. Likewise, you have t-test and z-test and rank sum test, Minkowski test, ranks sign test. Various tests are available which are assuming something in the sense which are for specific purpose. Some assumes that it is for normal distribution, some assumes that it is not for a normal distribution, and so on. So we are not talking about what is the assumption, but what I'm talking here now is how to apply those tests and how to make inference or conclude using those tests from the given data. So chi-square test is majorly used for categorical variables. That is important, and it is a non-parametric test. Non-parametric test, it is not assuming any assumption for the given population. So let us see how do we. There are other assumptions also for chi-square test, like you can do that for categorical variables and accepted frequency. Given data should not be less than 5. Now, how do you do chi-square test? Formula used is this: O minus E ka whole square divided by E summed up for all. O is observed frequency, E is expected frequency. So from the given data, you are going to calculate this OE, calculate this chi-square value. This chi-square value you are going to calculate, and how you are making to conclude. The conclusion will be based on this calculated chi-square value. So you compare this chi-square value with the given table value. So your calculated chi-square value is greater than given table value. It means what? You remember this acceptance and rejection region I told you just now? It was like this. Here is your critical values. Here are your critical values. So if your calculated this is your critical value given. This point is your critical value here and here. So if your calculated chi-square value is greater than given table value, given table value is this. If it is greater, it means where are you? You are in the rejection region. So your null hypothesis will be rejected. But if your calculated chi-square value is less than given table value, it is less than means you are in this region. Here, you are here. So your null hypothesis will be accepted. So rejection of null hypothesis means difference between the theory and observation is considered to be significant. That is, it is not because of the fluctuation in the sampling. There are some other reasons behind it. Now, what are the reasons? Statistics is not going to tell you those reasons. You need to find out what are the reasons based on your application or based on your work environment. It is just going to help you to make decision, but they are not decision makers. I hope statistics basic concept is that they help you to take decision. They are not decision makers. So, and if your calculated chi-square value is less than given table value, you are going to accept null hypothesis. That is, accept null hypothesis in the sense difference between theory and observation is not considered to be significant. That is, there minor variations is always there in the sample. So those variations are just because of sampling or fluctuations. There is no major reason behind it. You can ignore those variations. That is how that conclusion has to be made. Example, for example, in an anti-malarial campaign in certain area, quinine was administered for 812 person. Quinine was administered for 812. Now, out of these 812, 20 got fever and 792 did not get fever. Remaining 2436 total, 3248 person were total population was of 3248. Out of this, 812 were on quinine and 2436 were not on quinine. Quinine, out of this 2436, 220 got fever and 2216 do not got fever. So you need to, given this data, you need to discuss whether quinine is helpful in checking the malaria or quinine is useful for in checking malaria or not. You need to discuss this based on this given data. So you need, normally what happens is, given is the problem statement, you need to find out which test is best, which test will be best suitable for given this application. So here we can see this is a categorical kind of thing. So we are going to apply chi-square test. So chi-square test formula was O minus E whole square divided by E summed up for all. So let us do that. 20, like so for example, quinine 20 was having fever. So O is observed frequency is 20, observed frequency no fever is 792, observed frequency for no Kunan fever is 220. This is given actually. You need to calculate E now. How will you calculate E now? E is calculated as row and sum, row sum and column sum multiplication divided by total observation. Like for example, 20 is occurring here. Row sum is 812. 20 ka column sum is 240. So E will be calculated as 812 multiplied by 240 divided by total observation is 3248. So it will give you 60. Likewise, for 792 no fever, expected frequency will be row sum 812 multiplied by column sum 3008 divided by 3248. So we'll give you 752. Likewise for this, you will get this, you will get this. Now formula was O minus E whole square divided by E and summed up for all. O minus E for this will be, O minus E will be 20 minus 60, 20 minus 60 whole square divided by E is 60. For this, 792 minus 752 whole square divided by 752. For this, it will be 220 minus 180 whole square divided by 180. For this, it will be 2216 minus 2256 whole square divided by 2256. So, values calculated, these values calculated should be summed up. All this and this all summed up will give you chi-square value. So this is done here. So these values has to be summed up, this and this. So you will get 38.393 and given table value is 3.84 only. So what is the conclusion? Your calculated value is greater than the given table value. So it means what? You are out of your critical value. It means your null hypothesis has to be rejected. And what was the null hypothesis? Null hypothesis is always formed that something that particular thing has not happened. Nothing has happened. Nothing has happened in the sense Kunan is not useful or no difference in the cases. Even if you use Kunan, so Kunan is not useful in checking malaria was our null hypothesis. So that null hypothesis is rejected. So what it says is rejected null hypothesis in the sense Kunan is useful in checking malaria. So based on given data, it says that Kunan is useful in checking malaria. So that is how you can conclude from the given data. T-test is also there. Chi-square test was for categorical data. Now T-test is for numerical data, where it helps you to find out, it helps you to conclude something between the means of the two samples. Now those two samples can be independent, those two samples can be dependent also. Two samples independent, formula used is this. I'll just tell you how to use those things and what kind of samples you are saying that are independent or dependent. These formulas are there in the books also. Formula is this: x1 bar minus x2 bar. Now you are talking about two samples. So two samples in the sense you have mean of one sample, mean of second sample, number of samples in one, number of samples in two, and SV is your standard deviation. Standard deviation, you know, two sample standard deviation can be calculated like this. Standard deviation is always that value minus mean of that whole square divided by number of observation minus 1. So now you have two samples. So x1 minus x1 ka mean plus x2 minus x2 bar mean whole square divided by n1 plus n2 minus 2. n1 minus 1 plus n2 minus 1. That is n1 plus n2 minus 2. Take the square root will give you standard deviation. So you calculate this, all these values, data values are given. So calculate this and calculate T statistics. Now after calculating T statistics, T table is, critical values of T table is given in the books. All books, behind all statistics books, you will find different tables of T, chi-square or F test or Z test. Every table's values are given based on what is degree of freedom and what is level of significance you are, at what significance level you are doing the test. So now calculate this T and compare this T with the given table value and make conclusion. If your calculated value is less than the critical value, you are going to accept the null hypothesis. If your calculated value is...
Madam, excuse me, madam.
Yes.
Madam, one doubt actually, I don't know much about this thing. But normally the chi-square value and all, it's a very less fractional value, right? So I think the previous slide it is showing 38 point something like that. But normally these are all the error finding statistical things, right? So normally it will be the very fraction close to 1 or some fractions, right? I
Yes,
don't know whether.
yes. It happens. It
Yeah.
comes normally around this 3.4. If you add up all these values, they are in fractions. But your date now, but it depends on the data. Like for example, here this value is 0.79. This value is 2.12 only. But these values are
Okay.
higher. This and this value is higher. That's
Okay,
why it
okay.
is coming out 38. But it is no.
Okay, madam.
Yes. Yes, your understanding is correct. But it happens. It depends on the data also.
Okay, madam. Thank you.
So let us take an example for this t-test where we are checking the two sample independent samples. For example, random sample of 10% fed on diet A for increased weight in pounds in certain periods were this 10, 6, 16 and so on. For another sample of 12% fed on diet B, increased weights were this 10%. Now these 10% are different and they are fed on different diet A and diet B. So these two samples are independent. Diet B is not depending on diet A. Diet A is also not depending on diet B. Okay, so these samples are independent. So and these samples, so we can apply t-test for independent samples, and 10 samples here, 10 samples here. So total samples, what you need to do is you first have to form the null hypothesis. Null hypothesis, I told you, null hypothesis is also always formed when we assume that nothing has happened. So we assume that null hypothesis is that diet A and diet B do not differ significantly as regard their effect on increase in weight is concerned. So we are saying that diet A and diet B are same, they are not different. So what we do is these data values are given, this and this data value is given. One sample has 10, another one has 12 samples in it. This has 10 data sample and this is of 12 data samples. Here, these are 12 data samples. So what we do is we have to apply the formula. So we did some calculation. We calculated the mean of this. We calculated the mean of this and then subtracted this and taken the square and all these things we did. And we applied the formula. We calculated the S, the standard deviation, and then we calculated the T value, that is mean of X1. X1 का mean minus X2 का mean, that is 12 minus 15 divided by standard deviation multiplied by the formula is like this. T is X1 bar minus X2 bar divided by standard deviation multiplied by N1 N2 upon N1 plus N2 minus 2. No, sorry, N1 plus N2 on N1 plus N2 only. Sorry. So this is like this. Formula is this. So we have X1, these values with us. So when you calculate this using this, you will get 1.51 and given table value is 2.09. So you are in the acceptance region. Acceptance region, why? Because your calculated value is less than critical value. So your H0 is accepted in the sense assumption what you made is correct. Correct in the sense diet A and diet B do not differ significantly. They are similar. But if you look on the data, it doesn't look similar because these data values are quite different than these data values. So just by looking at data or by doing some descriptive analysis, you won't be able to make out those type of conclusion. Inferential statistics helps you to make those types of conclusion from the data. T-test can be applied for, how much time I have? Okay. So a t-test can be applied for two samples which are independent. Independent nahi. Now we are talking about dependent sample. Formulas are this: D under root n upon s. S is standard deviation. D is the difference mean mean of difference of those two samples. N is number of samples. And how do you calculate s? S is standard deviation calculated using this formula. So let us do it with example. Now, to verify, example is to verify whether a course in statistics has improved the performance. A similar test was given to 12 participants, both before and after the course. Original marks were this, and after the course, marks are this. So you need to say on the statement that was the course useful or not. Before test and after test marks are given, you need to say that course was useful or not. So you have data with you, you can apply t-test of which sample? Dependent sample. Now why? Because these are the marks before the test, and these are the before the course, these are the marks after the course. So samples are dependent on each other, they are not independent, because 12 participants are same, plus both participants were tested before the course and after the course, so they are dependent on each other. So null hypothesis, that no significant difference in the marks obtained before and after the course, that is course has not been useful, is my null hypothesis. I need to test it. So given these values, before test marks are given, after test marks are given, find out the difference between before and after, keep the sign as it is. You will find somewhere you will see marks are improving, somewhere you will see marks are not improving, they are decreasing. Here you can see. So you calculate this D, find out this D, sum of D ka mean of D, find out, and find out D square also, and put the values in this given formula will give you value of T, which is in this case, which is 3.4, and given table value is 2.201. So your T value is greater than T given. So what is conclusion? H0 is rejected. What was H0? H0 was that course is not useful. So H0 you are rejecting in the sense course is useful. So likewise, you will have many tests. I just gave you 2 or 3 example tests just to understand how inferential statistics can be applied for it can be applied to many different cases. Like we have worked on the as some case studies in educational domain. So if you are interested, I can just brief you what we did in educational domain, how we applied statistics here. Should we?
Yeah, but please.
Yeah, okay. So what we did is we tried to analyze whether active learning strategy is helping student in higher education or not. Active learning deals with applying different uh, teaching students using some different strategies, and not classroom teaching. It is through problem solving or through implementation of case studies or discussion, think, pair, share, flip classroom, role play, quiz, gaming, or other pedagogical methods. So what we did is we tried to implement role play and case study implementation for 2 different subjects, and we tried to analyze these 3 questions: whether do the use of active learning strategy in active learning setup affect student skills, or it affects students academic achievement, and it affects student satisfaction also. So for this checking for the student satisfaction, we just simply took the feedback, so that is not important. Student skills and students academic achievement, we did the statistical analysis on this. Now what we did is we have the we asked the student to implement, because we have CO based learning, CO based learning in the sense We form COs for those particular subject or those particular contents, and those COs we measure how many students scored greater than 60, less than 60, and so on. So one CO was of case study implementation. So we measured, we asked students to implement case studies for statistics for computer science subject in last these 4 years, 18, 19, 19, 20, 20, 21, 21, 22. Number of students were different as all students do not opt for this elective course. 18, 19, 51 student opted, next 85, 110, 130, and so on. Number of students performed greater than excellently, that is greater than 90%. These were the count. Performed greater than 80%. These were the count. So we just wanted to have a look whether this case study implementation is effective, or they are is this helping in their overall evaluation also. So we measured this for one CO, and we measured this for all COs also. All CO in the sense program level, in the sense ESC results. So ESC results we again did same 90%. How many students got greater than 90? So these were the data for all 4 years. Greater than 80, these were the data for all 4 years. So we have this data, and now we wanted to analyze is there an improvement because of case study in ESC results also, apart from that CO. So what we did is, likewise we did for role play also. We have one role play implementation. We took one topic and we asked students to implement role play, and we marked evaluated students for that role play implementation also. And we observed the ESC results also, where we implemented this role play strategy. So we have this data with all of us, with all this data with us, and we applied chi-square test. Now the chi-square test which I discussed, that was a chi-square test done for the as a non-parametric test, but then chi-square test is applicable for checking the distributions also. So we use that chi-square test for one-way classification strategy. So we calculated some other technique is involved with this. So we calculated this, E values and O values are given, and we formed the null hypothesis, and a null hypothesis that student performance is equal in all years. It means we, considering that we are not doing anything, so student performance is not getting affected. So student performance is equal over all years. And alternative hypothesis we formed is performance is increasing over the years. And we calculated the observed frequency. Observed frequency was given, I told you in the table, previous tables, and we calculated E for all, and we calculated this chi-square value, and the chi-square value calculated were this. For this case study implementation, table value was this 7.85 for that degree of freedom 3, because we have 4 years data. So degree of freedom is always -1 for -1 samples. So this all values were greater than this. So we are in the rejection region, in the sense we rejected the null hypothesis, in the sense we accepted our null hypothesis that that case study was useful. So that way we did the analysis for all, and we got good results. All results were saying that active learning strategy which we implemented, they were effective. And we did the same thing for think pair share also. Before test and after test, we analyzed the marks. 25 samples we took randomly, because class were of 250 students. So we took randomly the samples. Pre-test and post-test marks. If you we analyze those marks. So excellent has increased, average decreased, poor has also decreased overall. And these were the this color, orange color are post-test marks, and blue colors are pre-test marks. So you can see somewhere it is up, somewhere it is down, somewhere it is going down, somewhere it is up. So we analyze that using t-test. Is the performance improving or not? We applied t-test, but then t-test of dependent sample. So in this case also, we got the result that null hypothesis is rejected. That is, it is improving. Think pair share has improved the results. So that is all from my side. I have few slides for R. I told you R and Python have very strong methods available in it. You can do statistical analysis. Methods are available. You can just pass on the data. It will do everything for you. Like for example, t-test or chi-square test or whatever test you are, a linear regression, correlation. You just pass on the data. You don't need to go into the mathematics behind it. You don't need to code it for it. You just specify the data and work. It will give you good results. So I have those things. If anyway, I'll share the this PPT with you. You can go study on your own maybe. Like for example, calculating mean, you have a direct function called mean. Just pass on the data. For example, C is a vector, how to form a vector in R, and it will print the mean of this data. Likewise, it will print the median of the data also. R doesn't have mode function, mode to work on. You need to write the function of mode, will give you the result of mode also. Standard deviation also function is there, SD, or you can write your own function also. Variance also you can calculate using VAR function, or you can write your own function. Here you can write your own function also. Likewise, variance quantiles also can be for this data. What is the 0% minimum value, maximum value, median, and this is first quartile, this is third quartile. So it can print using quantile function. It will print all. You can print summary, head, correlation also. You can find out COR function between this and this variable of this data set, will print the correlation. And LM is the formula used for regression, I told you. So you can find out, like for this example, this is your scatter plot of the data. If you fit this LM function or this is your best fit line. You can print this in R using AB line function and LM function. And summary, you can see this summary also can be printed. Summary of M1 will print intercept, floats, everything it will print. Minimum, maximum, everything it will print. And after this, you can predict also. You form the data in M1 and do the prediction, will predict everything. Will print prediction result. Likewise, you have many functions. So any questions?
Thank you so much, madam. Friends, if you have any query, please ask.
I was too fast.
The topic is vast actually.
Yes, correct.
Yeah, it was very nice, madam. Yeah.
Excuse
But
me,
I
ma'am.
think it's very,
Yes.
yeah, it's useful
Hello.
for theoretical people. Yes.
Ma'am, again, it is if we are using a statistical analysis to a particular data, so shall we write the same process for whole data? We shall repeat this process, or according to our problem, we have to use different analysis. Because this is new for me, that's why I'm asking.
No, based on your application, you find out which is best suited for your application.
Thank you.
हेलो
Yes, sir.
हाँ मैडम, आपका वो आर प्रोग्रामिंग का बुक है ना, कैन यू शेयर
हाँ।
दैट बुक?
बुक शेयर नहीं कर पाऊंगी क्योंकि उसका सॉफ्ट कॉपी नहीं है मेरे पास में.
Madam, kindly give us a detail.
You can see this book. I have written that in references. I'll give you the details.
Okay. Is it online available,
which
ma'am?
one is best on
Online, I think it is not
statistical tools?
available.
Okay, ma'am. Ma'am,
Yes, sir,
Latesh
please.
Malik, madam.
Uh,
Latesh
ma'am,
Malik, madam,
which
is also there as a author, na?
Yes.
And she is from Nagpur, so we can
Yes.
contact her.
You can contact if she has copy, maybe she will give you one copy.
Yes, ma'am. Yes.
Yes.
Yes,
Yes, sir.
anybody? Any
The
question?
R programming is actually purely statistical methods, no? So it is not a live program with electronics or some
Ye-
interfacing is not that much possible.
No,
It's fully
no,
for
no.
statistical
Yes,
simulation.
statistical
Yes,
methods majorly, and
methods.
sometimes people use for machine learning also because functions are available there.
Okay. Which one is best, madam? Which one is best for interfacing this one? I think LabVIEW or Python, or which one is good actually for the accurate measurements for the live?
Nowadays, if you need to choose between Python and R, they are going hand in hand because some companies want some code to be written in R. But majorly, if you ask me, 60% people are compared to like 100% people are there. So 60% are using Python only. Python is more
Okay.
rich than R.
Yeah, everywhere is Python. I think school students
Yes.
also
School
they
student
are
also
using
writing. Yes, yes, yes.
they
We,
can-
yes. We have another book coming out for data analysis using Python, which includes some things for machine learning also.
Okay,
Okay.
ma'am.
Thank you. Thank you.
Any more question? Ma'am, you kindly share your number in the chat box.
Okay.
You just click on stop sharing, ma'am. Then you will
Stop
get.
sharing, but then I am not getting this.
Madam, at the header region, just scroll down your mouse to the header region, then you will get stop sharing option.
Scroll down.
Else, I'll do it from my side, ma'am. Just a minute.
Yes, I got it. Yes, yes, yes.
Yes.
Stop
You share
sharing.
your number and mail ID, ma'am. Yes, ma'am. So I think there are no questions now. So thank you so much, madam. On behalf
So
of
much.
UGC HRDC Nagpur, I extend my thanks to you, Dr. Sandhya ma'am, for wonderful and informative session with demonstrations. Thank you so much, madam.
Thank you, madam.
Thank you so much. Thank you, all of you. Thank you, all the participants.
Thank you, ma'am.
Thank you. Thank you so much. Now you can proceed for your lunch break. Our seminar session will start from 1:30. Am I audible? Are you all there?
Yes, yes, ma'am.
Yes,
Huh.
ma'am.
Just a minute. I just show you the today's task. Can you all see the screen?
Yes, ma'am.
Yes.
Ma'am.
So in today's section, yesterday's section is also open. Those who have not yet completed this task of Moodle and everything. तो कल का भी सेशन ओपन ही रखा है. आपको ये 25 नवंबर तक कंप्लीट करना है. But related to this yesterday's task, I have mentioned one question today. Can you see this task related to 21st November? दिख रहा है आपको? Yes.
Yes, ma'am.
So there is first part is report submission. आज एक ही लाइव सेशन था मैडम का जो अभी हुआ, उसके ऊपर आपको रिपोर्ट लिखना है. शॉर्ट में लिखेंगे क्योंकि बहुत सारे टेस्ट मैडम ने कवर किए हैं. जस्ट मेक इट शॉर्ट, जस्ट एब्स्ट्रैक्ट और इन द फॉर्म ऑफ पॉइंटर्स यू कैन राइट रिपोर्ट. देन देर इज क्वीज ऑन द सेम टॉपिक. रिपोर्ट सेशन 1 के ऊपर मैडम ने कुछ 5 क्वेश्चंस भेजे थे, तो 5 क्वेश्चन का अपना क्वीज रहेगा. सिंपल क्वेश्चंस है. And the third one is submission of Moodle site. Yesterday, if you have gone through the videos of Sunday, so आप लोगों की शायद Moodle site create हुई होगी, नहीं हुई होगी तो आज आपको ये वीडियो देख के आपको क्रिएट करनी है। किसी ने ट्राई किया था ये सारे वीडियोस देखने के बाद साइट बनाई थी किसी ने? एनीवन?
यस मैडम,
Yes,
बनाई
madam.
थी। यस मैडम, बनाई थी।
Yes, madam.
यस, आपने जो साइट बनाई होगी मैडम, उसका नाम जो भी होगा वो नाम आपको आज के सेशन में लिख के भेजना है, सबमिशन ऑफ मूडल साइट। और जिन्होंने नहीं परफॉर्म किया है उनको आज परफॉर्म करना है। तो आपको सारे वीडियोस तो आज नहीं देखने हैं, आपको ये जो मूडल सेशन 1 वाला पार्ट है ये आज आपको देखना है, और बाकी की चीजें आप लोग धीरे धीरे सॉल्व करिए। बट द लास्ट डेट ऑफ कंप्लीटिंग ऑल द टास्क इज 25th ऑफ नवंबर। तो कल का संडे था, तो आपने ये सारी चीजें कर लेनी चाहिए थी, बट अभी आप देखिए आपके ऊपर डिपेंड करता है। ड्यूरिंग सेमिनार सेशंस ऑल्सो यू कैन डू एट योर एंड। जिनके सेमिनार से वो तो चलते रहेंगे, बट जिनके सेमिनार नहीं है वो लोग आप ये वाला टास्क शुरू कर सकते हैं। तो आज आपको 3 चीजों का सबमिशन करना है। टुडे देर आर 3 डिफरेंट सबमिशन। वन इज रिपोर्ट सबमिशन ऑन द फर्स्ट सेशन, क्वीज ऑन फर्स्ट सेशन एंड सबमिशन ऑफ योर मूडल साइट। मूडल साइट जो भी क्रिएट करेंगे उसका नाम आपको सिर्फ लिख के भेजना है। फॉर एग्जाम्पल xyz.genomio.com, ऐसा कुछ अगर आप बनाते हैं तो वो नाम यहाँ पे लिख के भेजना है। आगे आप जो भी चेंजेस करेंगे वो ऑटोमेटिकली अपडेट होते जाएंगे उस साइट में। मतलब जब आपका मार्किंग होगा तब ये सारी चीजें उसमें कवर होनी चाहिए जो जो मैंने ये 5 वीडियोज में दिया है। आर यू गेटिंग?
Excuse me, madam.
यस।
Ma'am, I made it on Moodle Cloud.
Yes, no issues. But
No issues?
have you have not used genomio.com?
No, I use moodlecloud.com.
Okay, so you just go through this first video and create a new dummy site, or for demonstration purpose only. For this refresher course, just make one another site.
Okay. Then I have to put that link again because I gave the link of the Moodle Cloud already.
Okay. Then you just reframe that, or you just add these particular topics जो भी यहाँ पे डील किए हैं वो चीजें आप उसी साइट में ऐड करिए मूडल क्लाउड वाले। बट आप ध्यान में रखिए ये भी एक क्वेश्चन आपको मतलब इम्पॉर्टेंट है, क्योंकि मूडल क्लाउड साइट जो है इट इज हैविंग द वैलिडिटी ऑफ 30 days ओनली। अगर आप उसको देखते नहीं हैं तो वो डिलीट हो जाएगी क्लाउड से। तो ये जो genomio.com है इट इज हैविंग सम एडवांटेजेस ओवर द मूडल क्लाउड।
Okay, I will make another one and then I
Yeah.
will put
Yes,
it there.
sir. Yes. For practice, you just go through this.
Okay. Thank you.
Okay. So rest of the participants also, you have to go through these particular videos and try to prepare your own course by watching all these videos. So now I am ending the meeting. It's 12:40. We will meet at 1:30 for our seminars. So thank you all of you. If you have any question, please ask. Otherwise, I'll end the meeting here. Any question?
Madam, should we submit the Moodle site today itself?
Sorry?
Because,
Sir, please be louder.
should I submit the Moodle site today itself?
Yes. For today's assignment, there is one question, submission of Moodle site. So you just create that site today itself. And rest of the additional part you can do from tomorrow also.
Okay.
But till 25th, you have to complete all the topics. Those I have mentioned in the 5 videos. Okay. चलिए यहाँ पे रुकते हैं. We will meet at 1:30. Thank you all of you.
Thank you.
Thank you.
Thank you, madam.